Let's go ahead and do this. Metals, they take up the majority of the periodic table. Okay, they take about 80%, as you can see. All of these, even these down here, those are called the anthenide and lanthanide series. They're metals. They should fit right here, but if you place them in there, the periodic table will just be way too long. So just drop them down because they all have very similar characteristics and very similar attributes. Okay, so make sure you know that you have these differences on your periodic table. Okay, so they're on the left side, middle, and the bottom of the periodic table. Whoops. Non-metals. Non-metals are on the right side, and you have hydrogen right there. So just assume hydrogen isn't there. It's like up here all on its own. Because when I say like which region, and you see this region is like region 1, you're like, wait a minute, there's a gas right there. I can't choose that as all metals. Pretend it's not even there. It should be off to the side all on its own. But make sure you know that these right there are your non-metals. Now we have this group of non-metals right here with the name. It's group 18. Somebody came up to me and said, I only know groups and periods. How come you're saying columns? I don't know what these columns are. Columns are the same thing as groups. Columns are the same things as families. Okay, so if I say column 18, I'm talking about group 18 or family 18, known as the noble gases. Who can tell me one thing that's important to know about the noble gases? What's one thing? Anybody? One thing. Yeah, full valence shell. And what does that make the element? What does it make them? Not reactive, so we call that what? Stable. Because they have a full valence, these are the only naturally found elements that are stable, okay, on our planet. Okay, those are stable because they have a complete valence shell. You have to know the semi-metals. They're right here, like that little step ladder. The number one that you should know is silicon, which is right there. Does anybody know why silicon right now? Yeah, and what do we use those in? Computer chips. Silicon are the most important because they have two properties, one metal, one non-metal. The property of a metal that it has is it conducts electricity very well. Now, it doesn't conduct electricity as well as, let's say, silver or gold, but it does conduct very well. But it doesn't conduct heat. So that means you can run a lot of computations through a computer chip, but it won't heat up as fast as if you were using silver or gold. That's why it's very important, and it's used in all of your electronic devices, all the way from your phone to your television to your microwave, okay, to whatever you have electronic devices in. Acceleration is a problem that we're having still on our exams, and that's fine, and that's why we did this at the very beginning of the year, so we can keep coming back to it test after test. You have to know what these diagrams represent. The number one thing you do when you are asked a question and they give you a graph is you have to look at the y-axis. You have to look at the y-axis because that will determine what the shape of the graph is trying to tell you. This is a position time graph. It can also be written as a distance time graph. Same exact thing. And this is telling you right here that you're traveling at constant speed. So this is traveling at a constant speed. That's traveling at a constant speed, and that is traveling at a constant speed. The only difference is this one's traveling at like 30 miles an hour, kind of like a VW Bug, like an old school one, not the newer one, like a 70s version that's about to break down. Okay, 30 miles an hour. It's not going so fast, but it's still at a constant speed. This one right here is going like at 50 miles an hour. That's like your family minivan, still going pretty quick. Your parents got to get you to practice. Right, so they're kind of speeding down the road. And this one right here is like a Ferrari right here. It's going like 100 miles an hour. Notice, they're all traveling at constant speed, but your steepness of the line tells you which one is going faster. Now, over here, notice the lines look similar. They're going the same direction. They're going the same steepness, but it's telling you something different because of the y-axis is speed. These lines are telling you that you are accelerating. That means you are speeding up. Does anybody know another term I use for speeding up? Going what? Going faster. So these lines are showing that you're going faster and faster every second. Okay? But you have to see the y-axis is going to tell you that. Now, a flat line on an acceleration graph, that's constant speed. So if you see a flat line on this graph, that is telling you you're traveling at a constant speed. A flat line on a position or distance graph means you have stopped. Like you were traveling, somebody stops you when you're talking, it'll be a flat line. Because remember, the flat line means no, right? And so on here, this means no speed, so that you're traveling at a constant speed. This one is saying no position change. It means you're stuck. So that's what a flat line means. Just like when you're in a hospital, you get a flat line. That means no living, no more, right? All right. And then a line going downwards on an acceleration graph, that's slowing down. Now, how do we find speeding up and slowing down on a position graph? Well, speeding up is a curved line going up, and slowing down is a curved line pointing down. Those are the differences. You have to know the y-axis, though. That will help you out on those types of questions. You have to know what ionic bonds are, right? Ionic bonds are charged particles because of a different number of electrons, okay? So sodium is a positive ionic ion. Chlorine is a negative ionic ion. Opposites attract, right? So sodium and chlorine come together to form the crystal we know as salt. So that means ionic bonds are what form crystals, okay? So crystals are made from ionic bonds of regular repeating patterns. But it's ionic bonds. Too many people are selecting covalent bonds. Covalent bonds of regular repeating patterns, those are called polymers. And we're going to look at polymers in the end of Unit 5 when we look over organic chemistry, which is the chemistry of your living body. What goes on in your body when you eat food? Why does it make you, get more energy? Or why do you, when you eat things, does it make you more sluggish? That's organic chemistry, and it has to do with polymers. And the number one polymer we're going to talk about within your body is going to be protein. And protein is the number one thing that keeps you alive on an everyday basis. And a protein deficiency or an inadequate ability to create a protein in your body is one of the number one causes of disease or birth defects. Okay? You have to know what atomic masses are. Okay? We're still not understanding where atomic mass comes from. Where does atomic mass come from? From when we look at something like this, where does the atomic mass come from? What do we do? Yeah, protons plus neutrons. So what would be the mass of this carbon atom? What would the mass be of this carbon atom? Everybody. 12. Because you count up 6 plus 6. That's going to give you 12. How do we know that's a carbon atom? How do we know for a fact that that is a carbon atom, JJ? Yeah, the proton number. The proton number is the atomic number. The atomic number is your element number. So it's proton number 6, so that's atomic number is 6. So the element number 6 is going to be your answer. That's going to be carbon. Now, take a look at this carbon. We already said its weight is 12, so we call it carbon 12. So what do you think this next one will be? What is this next one? Take a look at it. We said this one is carbon 12. We said it's carbon because it has 6 protons. But we gave it 12 because 6 plus 6 is 12. So what do you think this one is? What would our thing be on the bottom? Carbon 14. Now, what can I ask from these questions? Well, I can say this. What is the difference between carbon 12 and carbon 14? What is the difference between carbon 12 and carbon 14? Who can give me there's many different answers you can give me. Who can give me one? Carbon 14 has more mass. So we can say that it has a higher mass. Absolutely. What else can we say? Which one? Which one has more neutrons? Yeah, carbon 14 has more neutrons. How many more neutrons? 2. So carbon 14 has 2 more neutrons. So make sure you understand what those numbers represent. And carbon 12 has 2 less. Okay. So I could ask you, what is the difference between carbon 12 and carbon 14? It could be either carbon 12 is less mass or carbon 14 is more mass. Just make sure you know what those numbers represent. Now let's look at this one. We know that this one is carbon because you have 6 protons. We know that this one is carbon because there's 6 protons. Is this one carbon? No, it's not. And if you look on your periodic table, proton number 8, atomic number 8, so element number 8, what is it? Oxygen. So that's oxygen. Oxygen what? Well, we have to count its mass. So this would be called oxygen what? What's 8 plus 6? 14. So that would be oxygen 14. Whenever you are given comparing elements, whenever I give you models like this and I ask you, compare, what is the number one thing you count? What is the very first thing you count when I'm asking you to compare? Protons, always. Because if the protons are different, the only answer you can give me is what? If the proton number is different, what can you say is different about the models? They're not particles. They're different atoms or different elements. Different elements. Okay, that's the number one thing you count. So if I said, what's the difference between this one and this one? You count the protons, different element. Done. It doesn't matter about ions. It doesn't matter about isotopes. If it's a different element, the rest goes out the window. You're done. Now we look at these two. What's the difference between, let me go ahead and clear the screen a little bit for you. It's kind of messy. What's the difference between this one and this one? Well, we count the protons. Proton 6, same element. So boom, scratch that one off. Okay, what else? Now, what's the second thing we count? The number of neutrons. This one has 6, this one has 8. So what's our answer? They're isotopes. Boom. Now what if I asked you this? Of these two carbons, which one is neutral? That's when we count the protons and compare them to the electrons. Neutral is when you have the same number of both. Okay, so look at carbon 14 and carbon 12. Which of these two would be considered neutral? Which ones? Carbon 12. Because you have 6 protons and 1, 2, 3, 4, 5, 6 electrons. Since you have the same number in both, we consider those neutral. Okay, what if I said, what is the ionic charge of this one? What would you say? What is the ionic charge of this carbon 14? It's negative. And it's negative because that means you have more electrons. That's what the negative means. It's telling you who's winning. And if we count 1, 2, 3, 4, 5, 6, 7, 8 compared to 6, then you know that your electrons are winning. And how much are they winning by? 2. That's why we get negative 2. What if I asked you to identify a positive ion? What would there have to be more of? Protons. Just count the protons compared to the electrons. That'll help you out. Sorry, we're doing a live recording, so I can't stop talking. Density. This was one of our number one missed questions. Okay, because you're not quite understanding that the only thing you need to know in density is what? What are the only two things you need to know? Mitchley, what is it? Mass over volume. That is it. And once you identify mass and volume, you're done. You just have to do a little bit of math. So when I see a problem like this, an object has a volume of 50 mils, where does that go? Where does 50 milliliters go? No, it goes on the volume. 50 milliliters is our volume. And it has a mass of 10. So where does that go? On top. It's a little number divided by a big number. So what does it have to be less than? It has to be less than 1. It has to be a decimal. Okay, and easy math, cancel out the zeros, 1/5. 1/5 of $1 is 20 cents. So our answer is 0.2. Okay, that's our answer, grams per milliliter. What if it doesn't give me this milliliter? What if it says that you have water that starts at that place, you put in your object, and it ends up at this place? What would you do with those numbers? Subtract. And what do we call that? Displacement, from that place to this place. And it's 50 mils. Okay, make sure you're just going nice and easy through these problems. This was the number 3 most missed question. Okay, we should not be missing this. We've been doing it for a long time. Okay, so if the math is having a problem, make sure let's figure that out. And lastly, starter number 9, I asked you to star and rainbow and leprechaun or whatever you needed to do to go back and look at how to do these questions, because this was the #1 missed question on the exam, because we're forgetting what our terms mean. Remember, molecular motion is the same thing as kinetic energy. And that means how fast particles are moving. In a solid, they're moving the slowest. So we would say they have low kinetic energy. Once again, that means motion. Solids have the lowest amount of motion. They're tightly packed and they're vibrating next to each other. So they can hardly move, like being in the front row of a concert. You're stuck there. You can't move. All you can do is bounce up and down. That's it. Okay? But we say they have the highest attraction. That means they're not leaving their partner. They're stuck in place. You have to know that. In liquids, they can now start moving around each other. So their kinetic energy, the molecular motion starts to go up a little bit. Not super high, but it's higher than your solids. And we say that their attraction now, okay, is weaker. And then finally for gases, they have super high, arrow up, arrow up, arrow up, super high kinetic energy. They are the fastest moving. And since they're the fastest moving, they're the ones that most likely are going to collide with one another. Those particles are moving so fast, they're bouncing off each other all over the place. If we put amphitheater and just said, get off campus, right? They would be going everywhere because we didn't give them any rules. One's trying to go straight, one's trying to go left. They're all hitting each other. They're just going to be colliding left and right. That's like gases. And their attraction, 0. They don't want to be near each other at all. You have to know these things. And you also have to know, how do we get from a solid to a liquid? How do we get from a solid to liquid? What do we have to add? Heat or thermal energy, right? Make sure you know the difference, that heat and thermal energy is the same thing. Remember, there is no such thing as cold, only the loss of thermal energy. Your brain turns the sensation of losing heat into the sensation of being cold. There is no such thing as cold. It's a rapid loss of heat from a part of your body. That's what we synthesize as being cold. Now, that is the end of our review